and welcome to How Do the Bad Guys Get In? Attack Vectors in the Modern Enterprise. We'll be discussing how today in the modern enterprise that went through digital transformation, cyber attackers can utilize attacks and what kind of attacks they do to get into your enterprise. Just about what are we going to be talking about? We'll define the cyber kill chain and focus on two steps inside of it, which will be the delivery and the exploitation phases of the cyber kill chain, the 7 steps. After that, we're going to talk about the actual threat map of the attack vectors that are utilized. So either email or collaboration, which are channels that people like file sharing platforms or ticketing systems. And then, of course, the web interface, such as just people browsing the internet and how attackers can abuse that to get in. And then, last but not least, we'll talk about your infrastructure, the actual perimeter, and how it can be compromised to get in. We saw a lot of that during 2020. After that, we're going to speak about the actual exploitation phases, which is a dive into binary exploitation and how that works. And then we're going to show some real world examples and illustrate what we spoke about. So, the cyber kill chain is a 7-step diagram that illustrates how attackers prepare, execute, and perform cyber attacks today. It always starts with the reconnaissance stage, where your digital footprint is then assessed on the internet to understand what kind of attack surfaces exist and how it would be easiest to get in, and with the most less effort. So the attacker is always looking for the least passive resistance when he approaches a target. We know that 90% of the cyber attacks today start in email, so that must be at least path of resistance. So that's why we have what we see the delivery here, but it's not always exactly email. It could be also just sending a network stream of data packets to the enterprise assets, or trying to share a file with you over the collaboration platform. Attacker then weaponizes his attack based on what he chose. And then what we're going to be talking about today is the delivery methods, and then dive into the actual exploitation. Focusing on delivery. So inside delivery, we have kind of like breakdown of 3 types of attacks. You can or data basically, could be packaged as a file, could be delivered as a URL for intent to be opened by a web browser, or what we call actual text, or data in its form of delivery that will be delivered. So take for example an EML file, which is just an email envelope which just contains text as instructions, but it's abusing trust of people, where it's impersonating someone that you know, and then the actual attack is nothing technically complex. It's just more of a deception and impersonation attack in order to get the user to do things on behalf of the attack. For example, to transfer $1,000 to a bank account. Okay, so the endpoint is very interesting. Actually, recently I just I asked on Reddit in the sysadmin group this kind of question. I was very surprised by the answers. The endpoints are pretty dormant. Endpoints we're seeing maybe 1 event, 2 real events. They were saying a year. It didn't even depend on the size of the organization, which was very interesting. So you had 12,000 people organizations, you had 100 people size organizations, and they were saying that the number of events is pretty low, which means that the perimeter solutions are doing a lot of work. So that's an interesting something to think about. Yeah, so it really matches what I saw on Reddit as well. That's you should be seeing, and also companies that I'm in touch with, they should be seeing about 1 or 2 serious events a year where they did bypass. If not, if you have a bit more than that, if you're at 25, I mean, you should be looking, thinking. I mean, we'll talk about their recommendations and stuff like that later. Cool. So let's move on. Moving on now, I'll be talking about every attack vector from the outside in. And let's start with the most interesting one, which basically all the cybersecurity companies say, and then like 90% of the attacks come through the email channel. So how are the attacks? How are they coming in? How do they look like when they come in through in email? So again, I'm reverting back to the definitions. We had file URLs and text. You'll see the text in the next slide. So in the file, we have mostly they come in as Office documents or PDFs. Okay, Office documents will either contain a memory corruption vulnerability, such as 0 days or 1 days, which means we'll be talking about this stuff quite a bit, or which we see a lot is macro code, malicious macros. So in Word documents, you'll see VBScript, which is used to download and execute payloads. So that's why they'll ask the attack person, the victim, to enable macros. And something that we've really seen recently go up in popularity, it's version 4 macros in Excel, where in 1995 or something like that, a version, Excel introduced a specific type of macros, which were you can add special functionality inside the cells themselves in a macro spreadsheet. And then recently it's because VBScript has been really targeted and abused, so the attackers kind of shifted to those type of macros, and then they evaded detection for a long time until the vendors kind of caught up with it. We see a lot of or seen a lot of uncommon file types, which basically means proprietary compression and archiving formats. So I don't know, we saw one called what was it, Golden Image Archives or UUD files. UUD files, which were very proprietary. But now, if the client has installed like an archiving program called like 7-Zip or WinZip or something like that that does support it, and the vendor didn't even know about this stuff, then you have some kind of evasion technique or some kind of get in through the holes like that. Basically, they just put an executable inside. So once the archive is deflated, the user will just execute the executable and they're in. Another nice method that we've seen and is pretty popular is a password protected either Office document or an archive. And then inside the body of the email, the attacker will put the password in and tell the victim, all right, use this password. And then if there's any kind of automatic parsing systems, they won't be able to open the password and then inspect the file. And then we have the whole world of sandboxes. So just a word about sandboxes. The approach for detecting files or any in cybersecurity, you always have two approaches. So it's either static or dynamic. Static being file parsers that statically analyze the file, and dynamic analysis would be actually executing the file inside a live environment. In this case, a virtual machine of usually it's Windows, but if you have Mac workloads, so also Mac. If you have Linux and workstations, also Linux workstations. And then observing the operating system and seeing what happens as the artifact gets detonated inside this virtual machine. So a lot of the attackers started getting smart because their attacks were being throttled by sandboxes. So back in 2010, FireEye brought in sandboxes. They're the first one who introduced it as a detection service for email security. And then the attackers started getting smarter. What would they do? Once they ran an exploit or gained a code execution, they would now delay the attack. So then they would go to sleep. They would call the sleep function for 5 hours. And then sandboxers are constrained for a certain amount of time of resources and time analysis. So they wouldn't detect the actual attack that runs 5 hours or 5 minutes after. And then that's how the attackers got by. More sophisticated methods were the attackers were using opcodes such as the CPU ID opcode to the CPU in x86, which gives the model and the specific data of the CPU. Now, virtualized environments didn't really virtualize that opcode, so it would be means to detect that the attacker is running inside a virtual machine, and then he doesn't have to, and then he basically has an if. So if I CPU ID equals this kind of value, then I understand that I'm in a virtual machine and I won't detonate and reveal my malicious intent. Moving on from files to URLs, today, what does an actual URL mean? A URL means that the attackers hold the artifact that can attack you on their servers, and that gives them a lot of power. So we've seen today that attackers sometimes can delay the delivery of the payload. It's actually not written in the bullets here. What they would do is, if they see that they send the emails at a certain hour, for the first 10 minutes, they won't release the payload. Doing this, that's how they can control if they give up the malicious intent or not. So this is a very, it's a very interesting way of attacking. Sometimes if the people really open the emails quickly, then it's a bad way of attacking, but it's one way of getting past security vendors. Phishing sites is an enormous, there's so much creativity done by attackers in this. The most easiest way or straightforward way that the attackers do is what they do is they surf to the site that they want to impersonate, copy paste the HTML, host it on their own site or their own hosting platform, and send a link to it. And then they just change the HTML that the credentials get saved into their own database, and then that's how they get the attack. But then we started seeing that they started getting very creative. They would use Google Forms or a SharePoint site. So by using the good and positive reputation of those services like Google Forms, so it doesn't look like the actual site, but some users saw that login, password, and username, all fill it in and insert it. So they really, sometimes the attack doesn't have to be very sophisticated, but it can be very creative in its evasion techniques. Another thing we saw that URLs, it's actually a form of file, but they host their files on cloud-hosted services such as Box, Dropbox, G Drive, OneDrive, and that's how they get positive reputation again in the delivery of the links. And sometimes the vendors don't even scan anything that's hosted on Google, because why would it be malicious, Because Google should be cleansing the files. So that was something that we've seen in the modern days that they're actually doing. And last but not least is what we call the drive-by downloads. So it's basically finding a vulnerability in the browser and then exploiting it, sending a link. So this is done by a technique that we'll talk soon about in the web area. The idea here is that, people said that, browsers are very secure. It's very hard to find exploits in all kinds of software. Just this month, 2 weeks ago, there was a competition in China held for people who can show that they can exploit Chrome, let's say, a browser, and then escape. So first memory corruption inside the actual renderer, then they need another exploit to get into to escape the sandbox, and then they need another exploit in the kernel to elevate the privileges, and then another exploit to escape VMware sandbox, like a virtual machine that they're living in. And not only did every software type, so like every browser such as Chrome, Safari, Edge is also based on Chrome today, was attacked, and Firefox was hacked and found bugs in it. Also, the operating systems and the virtual machines, so VMware was sandbox virtual machine escapes. So the whole chain was done multiple times. So this stuff still exists, which is pretty interesting that we're still 2021, and we'll actually be addressing that in the exploitation when we talk about the exploitation phase of the cyber kill chain. Moving on to the text that can harm you. we see a lot of this is something that's really been coming up in the last year or 2 years, is all the fake emails that are trying to look like someone that you work with or collaborate with. So the most simplest one is that the attackers do reconnaissance on the company, usually via LinkedIn. They can just see who the CEO is, who the CFO is, who are all the people. And then what they do is they just send you an email in their name. If the company didn't, and this is actually recommendations, if company didn't define SMT, what we call SMTP hygiene, such as SPF, DKIM policies, so then the attackers can just send fake emails in the name of that domain and that brand. So they would usually target you as with your own brand. Actually, going back to the previous slide, in URLs, in the impersonations, which reminds me, the most impersonated site for organization is the organization's login pages themselves. I'll repeat this. So let's say the organization has their own personalized portal. The attackers will find that portal and then replicate it and then attack the employees with that portal because they have the highest chances of succeeding the attack. Similarly here, they'll always try and impersonate, spoof you, or the CFO or someone inside the organization, or the CEO sending an email to the CFO. We even got, us as a company have been attacked by that stuff. It's very popular because it's very easy to automate. They just scrape LinkedIn, see who the names are, and then maybe open up a Gmail account in the name of the CEO and then start emailing people in the organization. Another going like a more sophisticated attack of this type would be where the attacker actually registers a domain that looks like the domain of the person that they want to attack, that they found in the reconnaissance stage. So let's say it's company.com, so they might buy company.com.au, or like the Australian domain of which obviously the victim didn't register, so then the attackers can use that, and it looks like that in your eyes, so then you'll think that it's really the person. Something that's come up even more lately in the last 6 months is what we see account takeovers. So the attackers are like kind of chaining their attacks together. So if a phishing attempt went successful, they'll now log into that account. They'll take over that specific email account in the domain. And then what they'll start doing, and we've seen this as well, they'll start replying to threads that have been already conversation that's been going on. So they'll either compromise a third-party vendor that you're working with and then just reply with we've seen this, they add in one of those maldocs that we spoke about, malicious documents or Excel sheets, and saying, oh, by the way, have you seen this? Can you please just answer this invoice, and then send you a PDF with a link inside or something, or a malicious macro inside a Word document as part of a thread that you've already been discussing. So you've already earned your credit. That person that there's already trust that's built between the two, and then they're just going to leverage that trust and try to attack you. Yeah, so that's the BEC and basically what we call text. Moving on to another attack vector, can be, which has really been, oh, by the way, I think we had some polls from before and I forgot. How many people here have been hit by BEC attacks? So the impersonation stuff, that's kind of interesting. Yeah, we have that. Have you ever, like, it's more of a yes, no question. Have you ever even seen that in your organization? So that'd be kind of interesting. And then we have another poll for the collaboration as well, kind of in the same same vibe. This is very popular type of attack because it's very easy to implement. Actually, another interesting thing that we've seen inside BEC type attacks is they spoof not only the from address, but also inside the SMTP protocol, you have the return path. So also that sometimes is spoofed. because they might send from one, but they want the reply email to go to another point. It also helps them with the credibility. So sometimes the from might just be a Gmail account or whatever, but the return path is another domain that they bought. And the thing is that they play around with these things in order to hit higher scores when a analysis system will try and understand the SMTP if that it's like in order and in line. I think we can close the poll by now. Cool, yeah. So we're pretty high. More than half the people here, about 60%, are saying that yeah, they've seen BEC and for sure. And then yeah, other people say they know what it is, but they haven't been hit. All right, that's pretty okay. It's actually the numbers are, I mean, they're not 100%, so at least that is encouraging. There's an I'll run the next poll in as I talk about this. So copy. There's a collaboration question. So what is the collaboration? So collaboration is anything that's basically the shared drives. So if you have a OneDrive or a SharePoint or a G Drive or a Box service, so we've actually been seeing attacks that come in through there, and as well as CRM systems. What are CRM systems? Salesforce is a CRM, and anything that has ticketing, and I'll talk about that. So let's first talk about the internal area. So what's internally? We've seen, Gobi, do you want to launch the attack? Launch the attack. Do you want to launch the questionnaire, the poll about collaboration, please? So we've seen that. Cool. We've seen that malware that sits on one endpoint scans the endpoint for a shared folder, which is collaborated via one of those collaboration platforms, and it starts editing files. So it edited documents like Word documents and inserted a malicious macro to the document. So this is a spreading mechanism inside the organization via weaponizing Office documents with malicious macros. This is something that we've seen and analyzed. So it's kind of interesting. I always thought of the collaboration stuff as more of an external vector, but it also acts as an internal thing. I mean, of course, we've seen how ransomware can also use that to spread. So the question here is basically, have you found, or has any of this malicious stuff got it to you via the collaboration stuff platforms? Looking at the externally, we see that people can just like share a file with you. Actually, my private Gmail, I always get this kind of stuff. People are sharing with me HTML files, and then the HTML files are basically phishing sites, which is quite funny. So you get a collaboration attack, but it's actually a file inside of an email, which is hosted on one of the things. It's like kind of like a mesh of all the attacks. So that's the thing that we see a lot. And then one of the most interesting is the CRM. So why are the CRMs very interesting? Because basically you're asking to be talked to or attacked via this platform. Because if an attacker can find a way to open up a ticket to your company or your service through one of these Zendesk or HubSpot or Salesforce systems, he can actually add an attachment there. So we actually saw a really sophisticated attack in Spreadsheet that came through this. Yeah, so about a third of the people have seen malicious stuff that came through this, and about half said that they haven't seen it. That really makes sense, and it's actually exactly as we see that as well. We see that about 30% in our clients that we have seen malicious stuff in their drives and that kind of stuff. So it's interesting to see how the numbers they really they match. So going back to that cyber attack that we saw through one of the CRMs, specifically Salesforce, is that the attackers opened a ticket and inside they attached a spreadsheet. The spreadsheet, this is when the Excel version, XLM, like so Excel macro version 4 from the 1995 that I spoke about was very popular. one of the macro codes that they can put there was os.getSystemAttributes or something. And attribute number 2 was to see if speakers were attached to the system. This was a sandbox bypass, which really impressed us, because basically virtual machines, if you didn't define speakers to be virtually attached to the system, then they would be bypassed. So like the attack would be aware that it's running inside a virtual machine, and it wouldn't detonate, and that actually happened, and we were very impressed by that thing. We had to patch our system because of that, but this means that via one of these collaboration channels, really like cutting edge attacks came in, and not just like the regular stuff that you can see on the day to day. So that was really interesting. So our next slide we'll be talking about the web, of course. So we talked about emails and the collaboration platforms, but obviously everyone just has a browser and they can just surf the internet. So how can they be attacked when they're surfing the internet? So we have a concept that's called water holing. Water holing is when the attackers compromise an internet site and then they put their malicious payload in the source code of the site. So then every time that a user surfs to that site, he pulls that payload, and then it can be run inside the user's browser. What can he do? Usually what they would do is they would run memory corruption bugs, vulnerabilities, and to exploit and install malware in the system. So that's what we call drive-by downloads that I spoke about on the URL section before. So water holing would be a form of delivery method for drive-by downloads and exploiting the browser. Then we also have another attack vector, which is hard to monitor in the modern enterprise, which is links that are getting in just via other channels such as social media or WhatsApp specifically, or if you're doing your Messenger on your Facebook app inside the browser. So you might be surfing and an attacker can give you a phishing link through there, or a link to a file as well. Anything that comes in through other mediums that aren't filtered through channels that the enterprise can control, which we saw before. The secure web gateways responsibility would be to filter this kind of stuff. Moving on to the perimeter. Okay, so a lot of the discussion I spoke about the perimeter, how it kind of changed from, on-prem firewalls and VPNs to SD-WANs. But we see that, especially during the pandemic in 2020, when we started and everyone started working from home, VPNs were really being targeted. You can see on the right-hand side here how in the past 2 years, a lot of new CVEs were disclosed and discovered in VPN-related technologies. And then in 2020, a lot of organizations were being compromised specifically through this vector. What happens after the attackers get in through the VPN? So what they do is they start scanning the network from within, and then they start looking for your crown jewels. What's your crown jewels? You're either production servers, so your production environment, or actual databases and stuff like that. What would they do with this data? They'll exfiltrate it, and then we've seen a lot of the ransomware attacks were like very popular through this attack vector. Obviously through the email, that doesn't, it stands and it still holds, but VPN was a very big breach area and attack vector to get into the modern, not the modern, actually the old enterprises, because modern enterprises are moving now to something that we call zero trust, in where every asset that you want to talk to, you have to be authenticated as you speak to it. And then it kind of just fizzles out the whole perimeter aspect, and then everyone's just sitting on the internet. And then if they want to ransomware your stuff, they have to break your identity and your authentication services instead of just hacking one little box that has a vulnerability in. Okay, so this kind of sums up the whole delivery and the whole area or phase of the cyber attack kill chain. Now what I want to do is I want to talk about the exploitation phase. And the exploitation phase has gone through a lot of has really evolved over the last 20 years. So it's kind of like a cat and mouse game between the software, anyone who's developing. I mean, we're going to dive into now like how the exploitation worked, and then a defense that came in order to stop that attack, and then how the attackers kind of bypassed the defense, and then how the vendors again responded with a solution, and then what the state is today. So let's go back to, we have a little cute GIF here that kind of explains how stack-based buffer overflows work. So back in the 90s, Aleph One introduced in the Frac magazine a article that he called "Smashing the Stack for Fun and Profit," which kind of introduced and kind of opened everyone's eyes to buffer overflow attacks and how they work. So basically what the attacker can do is he can control input that is transferred into the program. Now, we know in modern operating systems, every program that runs in its memory space gets kind of designated areas or memory sections for execution. It has the stack execution for every thread, and it has the memory allocation for the allocator for the heap, what we call for allocations that the program might need as it runs. And then we have the code itself, which is in the code segment, which gets executed as the program runs. Now, the program is basically a bunch of functions that call each other. Now, it kind of evolves and opens up into kind of like a Matryoshka style execution method, which means one function calls another function, which calls another function, and calls another function, and that's how it runs inside and so forth. Now, the program needs to remember where it needs to resume execution from the previous function that called it. So what it does is it has a data structure called the stack, and it writes the return address on the stack. So when it finishes executing a function, it goes, okay, where was I before? Looks at the stack, and then it hops back. It jumps the ret command in the assembly, pops that value from the stack, and then moves it to the program counter, which means what is the next opcode that's going to be executed. And then the CPU resumes execution from that point. So if the attacker can, so what happens? The stack also, it holds variables that might serve the functions that are being executed. So now if there's a bug in the code, which means a vulnerability in where the attacker, the programmer anticipated a buffer size 10, let's say, of information of bytes, 10 bytes to be filled. And then what happened was the attacker can input more than 10 bytes. So let's say he inputted 14 bytes, or actually in this case, he'll need to do 14. And then where he can override, or 18, he'll have to override the return code, and then he can transfer execution to his own place. Where is he going to transfer execution? To an area on the stack that he inputted, what we call shell code. Shell code is basically the opcodes that the attacker chose to run, which you can see here, and then he can now execute his own code. So now thinking about it, how can now we throttle this kind of attack? So if the attacker, by the way, in the heap, it's very similar. You had heap-based overflows, so where the attacker overflows the heap structures and then transfers execution to areas in the heap that he controls. He had to guess ahead of time where he'll be. That's he just transfers execution there, and then he runs his shell code. Now, how was this attack throttled? So in 2002, AMD and Intel came up with what we call the no execution bit. So I mean, there were some other attack methods that try to throttle that kind of stuff, such as stack canaries and of little software mitigations of that sort. But if the attacker had another vulnerability where he can read the memory, so what we call memory disclosure vulnerability, he can read the stack ahead of time, see what the value is, overwrite that value, and then adhere to the stack canary constraints. In this case, the memory is now hardware enforced, cannot be executed. So which means the CPU, when it transfers execution to a memory page that has the no execution bit, the CPU will check if the bit is on. If it is, it will throttle it would raise an exception and not execute that memory. So what do the operating systems do? They marked the stack area and the heap area as areas of memory that cannot be executed. And therefore, now that you can't execute them anymore, then if the attacker transfer control on them, he won't be able to attack. Cool. So everything was good. Everyone was happy. We can now stop stack-based buffer overflows or heap-based buffer overflows, and everyone was very, very happy. How do you think the attackers got around this, right? So if we can't execute code from the stack or the heap, where can we execute code from? We can execute code from the code segment because that's code that is meant to be executed. So introducing code reuse attacks. So just like in ransom letters, where the kidnappers send you an envelope that had, or a message that is cut out of newspaper letters and how they kind of put them together. Similarly here, the attackers will piece together little fragments of code from the code segment of the program called gadgets. And then we had three types of new programming ethics or programming of little gadgets depending on the opcode that they'd be used. So we have return-oriented programming, which would use the ret command, so which means the attacker placed a fake address of a gadget on the stack. We had call-oriented programming, cop, which means he would control pointers from the stack with gadgets that ended with a call command, or jump-oriented programming, which gadgets that ended with a jump, like jump EAX or jump ESP, which is based, they need to jump based on data that's on the stack. Okay, cool. So how is ROP attack will be throttled? So basically, up until 2016, but it's only coming into hardware now. It takes a long time for it to actually be throttled. Intel has introduced a technology called CET. So what actually happens in ROP? So ROP is basically, we have a control flow graph of the program. So ahead of time, the attacker, any program that you compile basically compiles into a big graph. Now the attackers, what they do is in ROP, they kind of break that graph. So what CET came to do is, let's make sure that that the program and the CPU is actually trailing on the real graph of the program that was intended by the programmers. How do they do this? They enforce it in two ways. The first way is any ret command that is issued by the CPU, it's always compared to another stack that exists in the CPU behind the scenes, which isn't accessible to anyone. So it's called a shadow stack. So every time you call into a function, that return address is now copied to another shadow stack. And then if the attacker kind of overrode that address, when the CPU performs a ret command, it compares where the CPU is about to jump to with the shadow stack. If it's not equal, throttles the program. An exception is raised and the program is smashed. Another message for calling for JOP and COP would be to mark inside the binary legitimate and legal places where it's allowed to jump to. So that means that the attacker number of gadgets is now very much reduced because there aren't a lot of gadgets that are possible for him to jump to. You're only allowed to jump to areas that you're allowed, that the CFG, the program which was compiled ahead of time, the appropriate nodes in that graph, which you're only allowed to jump to them. Cool. So now this is now being printed in silicon in the next versions of Intel chips. I think came in from Ice Lake, and maybe there's a new one that just came out. I think CET is already inside it. And Windows themselves are now slowly adding features in the operating systems to support these kind of enforcements for the control flow. It's called control flow enforcement technology. So how do the attackers get around this? So in 2016, a researcher in Germany from Darmstadt University introduced the Advanced Code Reuse attacks, specifically called Counter Freight Object Programming, COOP, in where the attackers are now going to adhere to the control flow graph of the program. But what they're going to do is they started abusing the semantics of the language. All right, so every time you push the attacker into a corner, he will try and find another area which hasn't been covered yet. So specifically, COOP abuses virtual tables and virtual functions in C++ objects in memory. What does he do? He finds a gadget we call a main loop gadget, which means a kind of like a virtual function table that will call, like a segment in the code that will repeatedly call a virtual table of a object. And then what the attacker does is, using his vulnerability, he would write a fake object in memory, and he would put the pointers into legitimate functions of virtual functions of certain objects in memory, and then he would just repeatedly call them, and then he would set the memory up that the functions side effects will write different and change the flow of the program based on the side effects that those virtual functions perform. It's kind of hard to illustrate now, but for example, he would manipulate a function that would write to a path inside, let's say the log path. Let's say, so inside the program it says, right, you should write logs to here. So he overwrites the path with those functions, and then he will find another virtual function that would execute a command based on that parameter, and then he would overwrite that log path with /bin/sh, so bin shell, and then he would pass that as a parameter to a function that will call os.system. So it's just over using the semantics of the language as a shield before you actually execute your own code or malicious intent. Another cool attack family that has been coming up is data-oriented programming, which is very similar to what I described. The attacker manipulates configurations or policies of the program through the data and not through the control flow at all, in order to alter and affect the control flow of the program, and then by side effects execute code on a program or a malicious program on the endpoint. A type of attack like this was in 2016, in where they manipulated 1 bit in the security manager object of Internet Explorer 11. It was called the security manager. They turned it off from to prohibit shell scripts or something. So they turned it was off, and then they turned it on by changing 1 bit in the data. And then they just ran VBScript and just ran their own shell, just because they could. So basically, who's doing all the attacks? Who are doing these things? So we kind of have two classes. We have the criminal hackers, which do this stuff for to steal your banking. Banking Trojans were very popular 10 years ago. Today, ransomware is really popular because it's monetizes really well. And then we have the whole side of the APT and the governments and the foreign nations doing espionage, what we call APT, who are using these kind of methods to get into organizations. A bit of stuff that we've been seeing in the wild. This is an attack that came out about a month ago, in where a new attack was found in a object handler in the Windows, where if you downloaded a CAD file, it automatically extracted it into directory traversal. And then the attackers found this and they started exploiting in the wild. I won't get into it because I don't have too much time. We still see this CVE running in the wild, which is fascinating. It's a 1-day. It's memory corruption in the equation editor. And we see that still running today, which is quite fascinating. And that's why I thought it's interesting to see. This is the Excel macro v4. So you kind of see like a code that's spread out all the inside here, which evaluates into something very, very malicious of download and execute. So it's kind of like the Salesforce attack that we saw before. This is the kind of stuff that we see they deliver executables inside either links or inside which a link downloads an ISO file, and then that ISO file opens up to a PDF, which is actually an exe file. Classic phishing. I thought we should just show that like all the time you can see Office 365 impersonation, and HTML as file attachments, which is hilarious, but people really fall for that. They just say, why give you a URL? We can just give you a file that you'll just put in your credentials there, and then they would be sent to our malicious sites. Yeah, and again, just a file inside the thing. Cool. So questions, and yeah, thanks.